Okay, the drug shipping problem. In the drug shipping problem, you were supposed to be representing a company that is producing drugs in 3 different plants and shipping them to 4 different regions of the country. Um, the cost of producing a drug at each plant and the shipping costs are included in the chart. So what is the cheapest way for each region to get the drugs that they need is basically the decision. Here is here's the data that's in the case. Well, actually, this isn't part of the data. This is something that I added in. So the data that's in the case is the amount to ship it to each area, the capacity that each plant has, and the demand that each region has. Now, you can't ship the region more than they want, and you can't produce more than you have capacity for. But because of this whole matrix, you need a matrix set of decisions. So you actually have 12 decisions. How much from each plant to send to each region? Okay, so I set it up this way, and then when you look at the amount that gets sent to each area, it's merely a sum of the column for each of these. And when you're taking a look at how much is shipped to each area, it's just a sum of each row. Now, when it comes to the total cost, I did 3 different sum products, one for each row. A sum product of this row plus the first row here, another one for Atlanta, and another one for New York. As it turns out, sum product also will work in a matrix, in a matrix of cells, so that you could have said sum product of all of this, comma, and then all of that, and you would have gotten the same answer. Once I got my model set up the way that I wanted it to be, then the question was, how do I optimize it? So you go into Solver, and your objective, of course, is your total cost, which you want to minimize, and then the next question is, what are your changing cells? And it's all of these in yellow. Now, I set all of my changing cells to be less than or equal to 14,000 because I was using evolutionary. You don't need it if you're using simplex. I'll get into the differences between the two later. But all of my decisions have to be integers, and all of my decisions have to be greater than or equal to 0. An argument could be made that because we're shipping tons of product, it's possible to send 2.5 tons or what have you. We'll leave that conversation for another day. But as you go through, you can see that I set the amount sent for each of these. I set them actually to be greater than or that the demand was less than or equal to the decision. Basically, you need to set it equal to. If you set the sent less than or equal to the demand, what will happen is because it's trying to minimize the cost, it'll actually decide to send nothing. So you really need to set it equal to, which is probably what I should have done, and I can do that now. So I want to add that that demand is equal to the amount sent, and that this demand was equal to the amount sent, and so on. Okay, so I have those set, and of course my amount shipped has to be less than or equal to my capacities have to be greater than or equal to the amount shipped in every case. And then I can hit solve. Solver goes off and does its thing, and it comes back with, it's not done yet, and it comes back with a solution that has a cost of $86,800, which isn't bad, fulfills all of my demand, and does it in such a way as to minimize the costs.